Hello, my lovely students. Welcome to the last series of videos. This is going to be on exponential and log equations. This is going to throw a whole lot of stuff together at once, but it does get represented on the final, so I want to make sure you guys get a chance to see it. So, first and foremost, the one-to-one property. If b to the s is equal to b to the t, then s must equal t, as long as b is not 1. Although if b was, yes, because then s wouldn't have to equal t, 1 squared, 1 cubed, whatever, right? And b also has to be positive. But this will even work for our weird fractional numbers. So if it's like 1.2 to the x equals 1.2 to the 7 plus 2x, we can set the powers equal, which is exactly what we're going to do here in number 1. So we have 2 to the x minus 1, 2 to the 2x minus 4. So they're both 2 to those. There's no extra things in there, so we can set the powers equal to each other. Now we're going to see in a few questions another way to handle it when the numbers are not the same, and that's going to involve logs. But for now, minus the x, and that'll give us our 1x. So I'm also going to add the 4 at the same time. So it'll be an x over here and a 3 here. And then on most of these, we do need to check. Now, exponentials can have anything as their input, so the exponentials generally work fine, but it doesn't hurt to check just in case. So 2 to the 3 minus 1 is 2 squared. 2 to the 2 times 3 is 6 minus 4 is 2. Yes, solution. Any equation that you solve is subject to being checked. If the solution doesn't work in the very original problem, I like to think of that as the printed problem. So just in case you have a habit of making a change from the screen to your paper, go back to the very original to make sure the solution works. All right, here we have 5 to the 2x and 5 to the 3x plus 2. Again, I'm going to be a little lazy. If I minus the 2x, then that would be 0 over here on the left, and 1x, which is just x, plus 2. And then I minus the 2. And we have our solution that negative 2 equals x. 5 to the 2 times negative 2 is supposed to equal 5 to the 3 times negative 2 plus 2. 5 to the negative 4 equals negative 6 plus 2, also 5 to the negative 4. All right. Now things get a little more interesting. I've got 8 and 16. Now this happens with some people. They look at this and their knee jerk is, oh yeah, 16 times 2 is 8, so I can change it to 8 squared. Pause, think, 8 squared is 64, not 16. So to write that equation so they have a common base, we actually have to go smaller than them. I can't take one number and write it in terms of the other here, but they are both powers of 2. All right, so that 8 is 2 times 2 times 2, so 2 to the 3rd. And then raised to the x plus 2 equals 16 is 2 to the 4th raised to the x plus 1. All right. Now remember, when we have base raised to a power raised to another power, the powers are very, very close. They only have the parenthesis between them, which is like the condom of math. So the exponents are close enough to multiply. Yes, I'm going to subject you to the cheesy math joke because I can. So this can be written as 2 to the 3 times x plus 2 and 2 to the 4 times x plus 1. I'm writing 12 times bigger than I thought I was, so we'll add some more space. All right, so this now becomes 3 onto x plus 2 equal to 4 onto x plus 1. Technically, we're taking log base 2 of both sides. The powers come down. Log base 2 of 2 is 1. 1 times anything is anything. So they cancel out. But there is a mathematical process that's going on behind the scenes. All right, now we need to distribute. So this is 3x plus 6 equals 4x plus 4. And then if I minus the 3x, I'll get a single x. So yes, please. And then to get x by itself, I'm going to go ahead and minus the 4 as well. So this will give us a 2. So x equals 2. So now we need to check. 8 to the 2 plus 2 is supposed to equal 16 to the 2 plus 1. So that is 8 to the 4th and 16 to the 3rd. Well, since 8 is 2 to the 3rd, this is 2 to the 3rd to the 4th, and 16 is 2 to the 4th, so this is 2 to the 4th to the 3rd. So they're both 2 to the 12th, so it does work. Exponential equations, as long as you didn't make a mistake, they tend to work. So if you're running out of time, don't check the exponential or the regular equation, but always check log equations. So we're just going to do this last one here. I'll just move it over here. All right, so we have a 5 equals 25 to the 3x plus 2. Two ways to see this one, but the standard way is to take the larger base and write it in terms of the smaller one. So I'm going to keep 5 to the 2x, and then the 25 I'm going to write as 5 squared instead. All right, so this will still be 5 to the 2x, and this one will be 5 to the 2 times the whole 3x plus 2. So we have 2x equals 2 times 3x plus 2. All right, we got to distribute over here. So still a 2x. This is now 6x plus 4. You know what? Let's actually just minus the 6x. Be a little less work. So now we have negative 4x. The only thing left on the right is 4. So final step is dividing by a negative 4. And we get the solution that x is negative 1. So back to our very original problem. 5 to the 2 times negative 1 is supposed to equal 25 to the 3 times negative 1 plus 2. So this is 5 to the negative 2nd, and this is 25 to the negative 1st. So 5 to the negative 2nd is 1 over 5 squared. 5 squared is 25, so 1 over 25. 25 to the negative 1 is 1 over 25. This does work. X equals -1 is our solution. All right, so exponentials, if we can write them all in terms of the same small base, we do.